Don't rely on built-in frameworks for your camera effects. To implement custom filters, you must first acquire the raw pixel buffer directly. On iOS, configure AVCaptureVideoDataOutput to deliver frames. Implement the CaptureOutput method to receive the CV pixel buffer. Crucially, set the pixel format to KCV pixel format type _32BGRA for direct texture upload, or use KCV pixel format type _420Y PCBCR8, biplanar full range if you intend to process YUV data directly. Before accessing the underlying data, always call CV pixel buffer lock base address. This ensures the memory is stable for reading. On the Android side, utilize the Camera 2 or Camera X API. Set up an image reader listener to receive the raw image objects. Access the data planes, Y, U, and V, using image.plane.getBuffer. If your device delivers the common NV21 UUV format, you cannot apply RGB filters immediately. You must perform a dedicated YUV to RGB conversion pass, typically using a specialized shader, before applying your main filter logic. This initial data acquisition step dictates your entire pipeline efficiency. Cross-platform shader development requires writing code that supports both OpenGL GLSL for Android and Metal shading language for iOS. We use GLSL 3.0 as the common source language. The primary difference lies in resource binding syntax. Metal requires explicit binding attributes. Uniform buffers use double bracket buffer index, while samplers use double bracket texture index. Conversely, GLSL uses layout location equals index for vertex attributes and relies on implicit bindings for uniforms based on their declaration order or explicit uniform block definitions. To manage this divergence, implement a pre-processing step or integrate a tool like SPIRV cross. This translates the GLSL source into MSL, ensuring the resource index mapping remains consistent across platforms. Define your vertex input structures identically in both languages. This consistency is mandatory to maintain a reliable data flow from the application layer directly into the vertex shader stage. Setting up the iOS Metal pipeline processes the camera frame entirely off-screen. First, instantiate an MTL device and an MTL command queue. Load your precompiled Metal shading language code into an MTL library object. Use this library to create the MTL render pipeline state, explicitly specifying the vertex and fragment function names. The incoming camera data, wrapped in a CV pixel buffer, must be converted into an MTL texture, setting the usage flag to .shader_red. For the output, create a second MTL texture designated as a .render target. Encode all rendering commands into an MTL command buffer. The critical step is configuring the MTL render pass descriptor. Bind the output texture as the render target attachment within this descriptor. Then, encode the draw call, binding the input texture and setting the pipeline state. Finally, execute the command buffer using command buffer.commit to initiate the GPU processing. Android requires setting up an EGL context specifically for off-screen rendering operations. Initialize the EGL display, the EGL context itself, and a puffer surface if the processed output is not immediately displayed on AGL surface view. To redirect the rendering output from the screen into a texture, you must create a Framebuffer object, commonly known as an FBO. Generate a unique texture ID using GLGen textures. Upload the raw camera frame data directly to this texture using GLTexImage2D or GLTexSubImage2D. Ensure the texture format parameter perfectly matches the format of the incoming camera buffer, such as RGBA or YUV. Next, compile your GLSL vertex and fragment shaders using GL Compile Shader. Link these compiled shaders into a single program using GL Link Program. Crucially, bind vertex attributes using GL Bind Attrib location before the linking step. This ensures the application layer knows exactly which attribute index corresponds to which shader variable. Filter parameters, including intensity levels, color matrices, or time variables, must be passed to the shader efficiently. Utilize uniform buffer objects, UBOs, in OpenGL and MTL buffer objects in Metal to group related parameters into a single transfer. Define a corresponding C structure in your application layer. This structure must precisely mirror the memory layout of the uniform block defined in your shader code. Map this CPU memory structure directly to the GPU buffer using GL buffer data in OpenGL or accessing MTL buffer.contents in Metal. This technique minimizes the number of individual uniform calls, significantly reducing CPU overhead associated with parameter updates. Always pass the texture resolution as a uniform vector. This enables accurate texture coordinate calculations within the fragment shader, especially when implementing offset-based filters. A convolution filter, essential for effects like Gaussian blur or edge detection, requires sampling multiple neighboring pixels around the current fragment. Define the convolution kernel, typically a 3x3 matrix, as a uniform array of floating point values. Calculate the necessary texture coordinate offsets based on the reciprocal of the texture resolution. This is 1.0 divided by U_resolution. In the fragment shader, iterate through the kernel matrix. Sample the texture at the calculated offset coordinates for each kernel element. Multiply the sampled color value by the corresponding kernel weight. Sum all these weighted results to produce the final filtered pixel color output. If precise pixel level manipulation is required for the filter effect, ensure you use nearest neighbor sampling instead of the default linear interpolation to prevent unwanted blurring artifacts. To minimize latency in your camera pipeline, reduce CPU-GPU synchronization points. On Android, employ asynchronous texture upload techniques. Ensure GL pixel store IGL_unpack_ alignment. 1 is set for tightly packed data transfers. Strictly avoid unnecessary blocking calls like GL finish or GIL read pixels. On iOS, utilize MTL command buffer.add completed handler for non-blocking completion checks, allowing the CPU to continue work while the GPU processes the frame. Deploy Metal shaders as precompiled libraries, .metalib files, to eliminate runtime compilation overhead during application launch. For Android, consider migrating to Vulkan instead of OpenGL on newer devices. Vulkan offers superior driver control and explicit memory management, which is crucial for maintaining consistent performance across the fragmented Android ecosystem.